So, dear students, in this chapter, thermal properties of matter, we have a few terms left out. Out of that, today we are discussing about reflectance, absorptance, and transmittance. So, these all are related to heat. The term reflectance, absorptance, and transmittance, all these are related to heat. So, for on a body, let Q be the total thermal energy, thermal radiation falling on it. Naturally, what happens is some amount of heat energy is absorbed by the material. This object can absorb some amount of heat energy, but some amount of heat energy is reflected back. It may not be absorbing, it will reflect back. But some amount of heat energy will be transmitted from one part of the body to other part. Maybe the part you give heat energy to another part, the heat is transmitted. So let Q be the heat energy given. So that is used for three purposes. One is for absorbing, the material will absorb, that is QA. QR is reflected and QT is transmitted. So that's what as an equation we are writing. Q is equal to QA plus QR plus QT. If we divide this equation completely with the Q, we get Q by Q, that is 1 is equal to QA by Q, QR by Q, and QT by Q. This term QA by Q is the actually value of absorptance, QR by Q is a reflectance, and QT by Q is a transmittance. So this is the relation between the heat energy reflected, absorbed, and transmitted. So look at this QA by Q, that is the absorptance. It's also known as absorptive power. It is defined as the ratio of thermal energy absorbed by a body in a certain time to the total thermal energy incident on it. Similarly, reflectance is the amount of thermal energy reflected from a body to the total thermal energy incident on it. This is transmittance or transmittive power, the thermal energy ratio of thermal energy transmitted to the thermal energy given to it. Now we have a term called emissive power. It is a heat energy emitted per unit area, per unit surface area, per unit time of a body for a given wavelength and temperature. For example, you take a body, a hot body, it will radiate heat energy outside. It will radiate out heat energy, or it will emit out the heat energy. The amount of heat energy emitted in unit time, when you divide this with the time, you are getting the energy emitted in unit time through unit area of the body. So this is called emissive power. Emissive power is a ratio of the amount of heat energy emitted per unit time per unit area through a body. Its unit is joule per second per meter square, or it can be watt per meter square, and its dimensional formula will be mt to the power minus 3. Similarly, we have one more term, that is emissivity, which is related to this emissive power. This emissive power of a body, when you compare with this emissive power of any body, when you compare with the emissive power of a perfect black body. A perfect black body means a body which can emit out maximum heat energy. So if you consider this emissive power of any body, compare it with the emissive power of a black body, which I represent as capital E, it is known as emissivity. For a black body, this emissivity is 1. For other bodies, emissivity will be less than 1. The black body is an object. It's actually an object which will neither reflect or nor transmit heat energy, but completely absorb the whole heat energy. So related to this emissive power of a perfect black body, there is a rule or a law that is called Stephen-Boltzmann law. Stephen-Boltzmann law. Stephen-Boltzmann law really gives a relation between the emissive power of a black body and the temperature of its surface. It is saying that the emissive power is directly proportional to fourth power of the absolute temperature on its surface. This proportionality can be replaced with a constant, and that constant is sigma, which is known as Stephen's constant, and it has a value 5.67 into 10 power minus 8 joule per second per meter square per Kelvin to the power minus 4. Similar to that, we have another rule, that is Wien's displacement law. So when a black body is emitting out the heat energy, corresponding to that heat energy there is a wavelength. This wavelength corresponding to which the energy is emitted by the black body at its maximum is inversely proportional to its absolute temperature. That is our Wien's displacement law. Then the law states that the wavelength corresponding to which energy emitted by a black body, whenever energy is emitted by a black body, there will be mm, a particular wavelength, and that wavelength is inversely proportional to the absolute temperature. In that equation we can write as lambda m, maximum wavelength is proportional to 1 by t, and there is a constant, that constant is called Wien's constant, and this constant has a value that is 2.9 into 10 power minus 3 meter Kelvin.